So, good evening, everyone. Myself, Dr. Subhanshu Padhi from Sambalpur University Institute of Information Technology, Bulla. And today we are going to discuss the triggering of SCR using DIAC. So, in the last two videos, we have discussed the triggering of SCR using R and RC firing circuit. But today we are replacing that R and RC firing circuit with a DIAC. Now, what is the basic limitation of R and RC firing circuit? The R and RC firing circuit are basically dependent on temperature. The R has a positive temperature coefficient with uh, res- uh, R has a positive temperature coefficient and the limited firing angle range of R and RC firing circuit. So instead of that, we are using a DIAC based circuit where most of the circuit components are same, where we have a AC source 120 volt RMS, we have a 120 volt 100-watt load, we have a SCR. These three components are same, and the SCR, the gate of the SCR is connected to a DIAC. The SCR is 2 and 5064, and this DIAC is 1 and 5758. What is a DIAC basically? DIAC is a two-terminal device, and this is diode for alternating current. And DIAC is used to trigger SCR or TRIAC, right? But in this circuit, this DIAC is triggering the SCR, and this is our RNRC firing circuit over here. We have a diode, we have a 4.7k resistance, we have a 100k pot and a 0.22 microfarad, and the pot is connected to the DIAC, and the DIAC on the gate terminal of the DIAC is and of the thyristor is connected to the DIAC. Now let's see the output voltage or the thyristor voltage as well as the output voltage of this circuit. Now let's run this simulation. Let's check the output voltage or the thyristor voltage over here. This is the thyristor voltage. You can measure the thyristor voltage over here by measure channel 1, frequency is 50 hertz, period is 20 millisecond. Obviously mean peak to peak is around 213 volt, and the cycle RMS over here, rise time, fall time, pulse width, negative pulse width, and the frequency period. And now we are going to get the 217 volt peak to peak or 207 volt peak to peak over here, thyristor voltage. Now let's check on the load voltage, average load voltage. See, as you can see over here, the average load voltage is exactly as we can see the output formula, mathematical formula is V0 equal to 2 Vm by pi 1 plus cos of alpha. And here, if we change alpha, the load voltage is changing. See over here, the load voltage is 169 volt to 176 volt. The mean is 50 to 16 volt. Now, if we change it, if we change the potentiometer over here, you can see the overall peak to peak is changing. After a little while, the peak to peak is changing. The waveform is also changing. That is 50 volt, and it is around 168 volt. And here, as we are changing over here, you can see the load voltage, the average load voltage is also changing with change of the potentiometer. That's basically the SCR triggering circuit using DIAC, and we have seen the low waveform for the circuit, the waveform for load voltage as well as the waveform for the thyristor voltage. Thank you.